Hello, everyone, and welcome to our Open Text Webinar Wednesday session. Welcome back if this is your third time joining us in our series. And if this is your first time joining us, welcome. I'm Susan Drennan, and I'm responsible for our North America-based sales team that supports our distributed COBOL customers. And I'm pleased to be with you today to host this session along with Jim Baum. There has been lots of interest in this webinar series, which I think you may be aware we are holding every last Wednesday of the month. The conversation has become quite interactive. Today, just so that you know, there'll be a presentation and then there'll be a brief demonstration. At the end of that demo, we'll have time for some questions. So as we go along today, please do submit any questions you might have into our chat window. And as we go along, we will be looking to address them at the end. So I'm looking forward to hearing from you all. We also should note that this is really an international session these days. We've had joiners joining us from all around the globe. It is a focused webinar series on developer interest in our solutions. If you look at the slide here, you see that we are mostly showing faces, smiling faces from our US-based team. But if you want to connect with us and you don't know who your sales individuals are, you're located somewhere around the globe, please just let us know, drop a note asking for a follow-up, and we will certainly connect you to the right people. Another note about this slide, this group of individuals, as you may know, are all moving to Rocket soon. The announcement that you might be aware of is that OpenText is divesting from the AMC division. That is our application, modernization, and connectivity solution group. And all of those solutions and all of these individuals, actually about 750 total, will be moving to Rocket Software. This will be happening, if on track, within the next several months. So just know that we are excited about this journey that we're on. We're excited to be moving to Rocket as our solutions align very closely with some of the offerings they already offer to market. The solutions that are going with us to Rocket include products you may be aware of, Serena, many of our host connectivity solutions, Reflections, Rumba, Host Explorer, our Corba-based solutions, of course, our distributed COBOL solutions, which we talk about here today, and then a lot of our mainframe modernization solutions, excuse me, including enterprise developer, enterprise server, and all of the enterprise solution stack that supports mainframe modernization. So we are enthusiastic, as I mentioned, and we certainly do feel like we are on a journey. And I guess as we go into this webinar series, we should highlight the fact that journey is a word you're going to hear a lot of today. During this series, we've been taking an application on a journey. We began the series in January, and in the first of those sessions, we looked at some of the embedded tools and techniques within Visual COBOL. So as a way to bring these functions to light, we've been working with a specific application and taking it on this modernization journey. That application in question is a simple COBOL-based application that handles a mortgage rate calculation. It might be simple, but it's an important piece of business logic, and it works as a great example of an embedded mission-critical application resource. You can think of it as code that a company might have been using for years to support their business community, and keeping this code will benefit that company and their business in the future. The point being, there is a great advantage in keeping your company application assets and extending them into a modern application landscape. You avoid the need to rewrite or replace. And these very COBOL assets can be exposed to, as I mentioned earlier, newer platforms, operating systems, and other programming languages. So as a recap, in January, we covered code improvement, which included code refactoring and code cleanup. In February, We showed how COBOL programs can be reworked into web services and then deployed as a service to a Docker container. So if you did not join us in January and February, I do encourage you to find those recordings. We've got those sessions recorded and they're in our course catalog on our Webinar Wednesday registration page. And you can go back there to review them. These demos set a foundation for the next step in the journey. And today we are taking the next step. We are going to continue with the same application today, and we're going to highlight how an existing COBOL program can be called by another language. So in this case, the demo you'll be seeing is based on how C# can call COBOL. You'll see the integration of functionality taken from the .NET framework, and it will be integrated into the COBOL code. So again, this is a great example of reuse and extension of an important piece of business logic. The last part of today's demo, you're also going to see that this COBOL service will be published to Linux and it will be running in Red Hat. Okay, so that's what we're up to today. But before we get there, we are also announcing our fourth topic in the series. In April, we will be looking at COBOL data modernization. There are various approaches available to any customer looking to build out relational databases from existing COBOL data. And that data might currently be an ISAM structure. During the April session, we'll explore a few options, but we'll provide a demonstration of relativity. Relativity is a solution we offer. It's a rapid data modernization solution, and it's offered out to our Micro Focus and RM-based COBOL customers. All right, so moving forward, let's talk a little bit about the tools you'll be seeing in this demonstration series. First off, as stated, COBOL is a modern language supported within various IDEs. In this case, we're seeing Visual Studio Code, and Eclipse. So any developer familiar with these environments, meaning a Java or a C# or other language-based developer, will find that they're now able to quickly learn COBOL and get access to COBOL. This gives developers the access to the legacy application environments regardless of whether they know COBOL already and what language they're in today. So developers can use their standard IDE to access COBOL programs and services and access them for integration with other application languages. In this series, we've been using both Eclipse and Visual Studio, so you've been able to see a little of two of these standard IDEs in use supporting COBOL code. Okay. Also, we introduced you to the latest version of Visual COBOL in this webinar series. Visual COBOL 9.0 was announced in July 2023, and it expands again some of the functionality with new release highlights. So, for example, Visual Studio Code was announced, as well as some improvements to unit testing and some new COBOL language features. We anticipate Visual COBOL to continue to get yearly releases. COBOL as a language, it's a fun course. The instructor makes it easy and clear. It really can support any developer that may already know a different coding language. And at the end of the one-day session, you'll get a certification. So we do encourage both our customers, our partners, and even the person sitting next to you, if you want to mention it to them, to take this one-day course. All right, so moving forward, let's focus on our application journey. I'll do a quick recap of what we covered in the first two sessions, okay? And how we've progressed basically to the point we are today. So again, on this journey, we're taking an existing simple program, a COBOL application. It's a good example of a snippet of COBOL business logic. It's a piece of legacy code, and we can imagine that this code has been supporting a fictional customer's business needs for possibly decades. It's a basic amortization application that calculates a mortgage rate. So you can see that as a classic COBOL usage. We use this application to firstly show code cleanup so that the code is easier to read. It's well formatted and follows basic standards. And this slide basically gives you a quick before and after. We then refactored the code. We utilized some of the refactoring tools available in Visual COBOL. They're also available, by the way, in Enterprise Developer, but we are focusing on Visual COBOL here. And this environment helps document the code and analyze its structure. So of note, there are various tools that help map and visualize the code flow. There are flowcharts and data flow tracking tools. All of this supports the important step of refactoring, which allows a developer, really with very little code change, to isolate a critical piece of business logic and expose it for reuse. So in the first session again, which was January, we showed how a developer could extract the complex code and dependencies and get them into a new program. This required restructuring. The code was restructured so the business logic was separated from the presentation layer. It left us with a simplistic piece of the business logic that could be used or accessed by other applications. Another benefit of refactoring, it also aids in making this code easier to maintain in future. It also allows it to be extended to other platforms and operating environments. So in effect, it allows you to make this business logic accessible as a service to other programs. And that's where we picked up the journey in February. So in February, we showed how to reutilize this refactored application as a service via an API. Again, the benefit here is that other applications, perhaps other application languages, can benefit from its value and function. So in this webinar, we showed how to design an API using the interface mapping toolkit within Visual COBOL. And again, once completed, this allowed us to take advantage of web services. We also then showed how to deploy this environment. In the deployment step, we showed how the new API can be published into containers, such as Docker containers. And of interest, this Docker environment, at the end of the demo, we showed was holding COBOL function where previously there had been no COBOL installed. Okay, moving forward. So I mentioned the interface mapping toolkit. We utilize the toolkit, the IMTK, to design a REST-based API. The REST-based API utilizes standard HTTP protocols and provide native as it is a time provided native as it is a time saver. It means you're basically reusing existing mission critical business logic, which is already in use in your application inventory and already supporting your organization. It allows for your organization to reuse this proven COBOL code to support new user environments and new user requirements. Not only do existing users benefit. Okay, so again, just clarifying, we designed a COBOL API. We deployed it to a micro-focused COBOL server, which could be local, or as part of this understanding, it could be located anywhere, even in a cloud or in a distributed environment. And we showed how this low-code approach would help to build new integrations with other languages. All right, so let's refresh on containers, on what it means to deploy to a container. In February, we showed how this COBOL service can be deployed to a Docker container. And this is a great value in containerization deployment, as containers can simplify your application deployment and accessibility. We explained that containers make implementation easier. Your application deployment is simplified by container technology as it holds all the code, libraries, and dependencies in one place. So why is this important? Basically, these are the necessary inputs that allow your application to run, and you would typically need to create the environment for deployment each and every time you wish to reuse this application. With the use of container technology, you can build the assets into a standard configuration for rapid and repeatable deployment. There's no need to worry about ensuring the underlying software is installed on each machine or where it's accessed. It's in the container. If your host and operating system supports your containerization tools, you're ready to deploy. And this can increase your speed to delivery. By breaking your application into services and optionally deploying these to containers, you can simplify the effort needed to ship code into production. And again, there's the cloud. When you are ready to move into cloud, and we do see many customers today taking advantage of cloud-based deployment technology, your container is already set up to deploy. It will run the same, whether it's deployed on premise, as you are used to, or to take advantage of the cloud. All right, so we are finishing up our recap from the first couple sessions. Again, remember that this has all been a legacy application modernization journey. That legacy application might have originally been tied to a single workstation where input was provided with conversational prompts, meaning a back and forth user input situation. The user would have been asked for a principal, a rate, and a term, one value at a time. And again, just to recap, we are talking about a mortgage calculator. So principal, rate, term, one value at a time with no ability to change options before running the report. Once the input was entered, a text-based report was generated that spanned many pages and required for all the detail lines. This was the starting point. This view was how we began. We then, without writing any COBOL code, we refactored the calculation logic, which in effect freed it up. It freed it up from the legacy character user interface, and we deployed it as a web service, which can now be invoked from anywhere and by any programming language. We then created a Java GUI, which provides a modern look, and this user experience became more refreshed. So it now provides the user with push button operation and a scrollable data grid to display the results. This Java GUI front end makes use of web service, reusing again being the key here, reuse, the core COBOL business logic. So we have modernized the application. We have made critical function originally written in COBOL available anywhere and to any language and with any new platform that is needed to support your user community. All right, so that brings us up to today. We are now at a point in our journey where we'll see the next modernization integration step, but they show different destinations. So we're not showing them both here on the webinar. That said, again, you can go to the course catalog. You will be able to pick the demo that is of most interest to you. And today is where you're showing the C# demo because it also has another integration. In this demonstration, we also show the .NET Core being integrated into the COBOL environment. So what you'll see is this. We've created a project. Jim Baum is basically going to walk us through a C# project, and that C# project will be referencing the COBOL project. And again, this is being done with no coding changes. You will see how C# calls the COBOL program and how the COBOL program passes data back to C#. In addition, we will show the integration of the .NET Framework functionality. In this case, we're using the current date calculator within the .NET Framework, and it will be utilized to provide a future end date calculation. So this framework function will be integrated within the COBOL program, which saves obviously a lot of coding steps. All right, and then lastly, we'll end up today with this program, which was originally built on Windows, being deployed to run on a Linux platform. All right, so I think that takes us up to our demo. I'm going to step into the demo now and then return at the end with a quick wrap up.
In this video, this program, and we'll just do that as we'll call that emahar for our, okay, so that's going to be the variable that we use, and we'll just do equals new. Okay, and now that I have that defined, I can pull the variables from it. So if I do emahar dot, I have all the different variables. So the input principal, for example, and then I can give that a name, and I can just continue working with this. So basically what I'm showing you here is that because we've compiled the emahar service program with smart linkage and referenced it in this project, I'm able to use IntelliSense to pull all the variables out of that. So with that example, I'm just going to delete this, and rather than having you watch me code a program, I'm going to import one I've already written. So for the C# emahar project, okay, I'm going to pull in my emahar calc C# program, and then I'll walk you through what that is. So I'm going to paste this into the C# project, and we'll take a look at this. So I've patterned this after the original program. So what this is going to do is define emahar as the input structure for the emahar service, emahar as the output structure, and then we're going to define the my program instance, which will be the program or the class. I'm going to set a couple of breakpoints. So I'll set one on user input, one on when we run the program, and one when we come back in the COBOL side of this to display the results. And I'm going to go over to my emahar service program and set a couple of breakpoints in here. So the first one I'm going to put is on the first line of the procedure division, and then I'll also put one on the go back line. So when we step into the COBOL program, the debugger will stop, and I can kind of show you how that portion of this works. Now, again, to this point, I haven't made any coding changes at all. So let's go ahead and run this and show you how we can have C# programs calling COBOL programs. So this is going to compile the C# version. I'd previously compiled the COBOL. Okay, and I'm just going to bring the window over here so we can see what it does as we step through it. So in the first section here, we're going to do a couple of write lines. So you'll see they're starting to appear on the screen here. Okay, and it's going to ask for the input. So we'll put the principal balance in here. Let's do 100,000. Hit enter, back in the debugger. I'm going to go ahead and continue. So we run the debugger until we get to the point where we call the COBOL program. So we'll do a term in months. We'll make this 60. And we'll do an interest rate. We'll make this 8.25%. Okay. And now we are in the debugger, and we're about to call the COBOL program from the C# program. So I'll step, and now we're in the COBOL program. And the COBOL program was passed the data we acquired from the C# program. So if we look at this, we'll see the principal that I just entered. Principal value here is 100,000. The term looks like that's 60. And the rate is the 8.25 I just put in. So this is going to go through and perform the exact same calculations as we've done previously. I'll just go ahead and continue these. And we've finished the COBOL program. Now we're going to go back into the C# program and display those results. So again, this is C# calling COBOL. Okay, and we'll just go ahead and run that to the end. And you'll see we've performed all the calculations with the COBOL program, passed it back to the C# program, and we're off and running that way. So that's great if I want to use that COBOL functionality without making any changes to it. But I want to also show you that we can integrate the C# or the .NET framework functions inside of the COBOL program. So I'm going to go over to my COBOL program, and what we're going to do is we're going to add some code that calculates what the end date of the loan would be. How many months in the future? So I had 60 months in this. What's 60 months in the future? Okay, so I have some snippets here. I'm going to just cut in here and then I'll explain them. So copy those. And then here in the linkage section, and this is what's being exposed to the C# program, I'm going to add system date time now function. And then I'm going to use this other .NET framework function where I'm going to add months to that. So the number of months that the loan term is, we're going to add to the current date, and that'll give us our .NET end date. And then back into the C# program, I have a line to display that. We're just going to remove that comment so that when we run this. Now, right now, you're seeing that this is showing with a red squiggly underneath. That's because that program hasn't been compiled yet. So the version of the Amort service program that has been compiled doesn't know about .NET end date. So we'll just pick that and we'll build the Amort service. And once this build completes, this .NET, there, my red squiggly went away because it now has resolved that. So let's run this program again and take a look at the changes. So I'm going to run the C# Amort again. Okay, and we're just going to continue past our first breakpoint. So one of the values, principal, we'll do 200,000. Term in months, we'll make this 10 years or 120 months. And the interest rate, we'll make this 7.5%. Okay. Now we're in the COBOL program, or the C# program, stepping into the COBOL program. So I'm going to add a breakpoint here. We'll just go ahead and run all the COBOL till we get to that breakpoint. So now you'll see that current date. Now let me step on that so that populates. Okay, so the current date is now January 9th, time that I'm recording this, and we're going to look 120 months into the future. So let me step on that line, and we'll see that the end date is 2034. So in COBOL, I'd had to write the code for doing that, but I can take advantage of framework functionality for anything .NET, and this is just a simple example of doing that. So now we'll continue out of the COBOL program, back into the C# program, and I'm going to put a breakpoint here on my outline. We'll run to that, okay? And now when I step, you'll see that we've passed our end date back, and we're adding that as part of the program. So I'll just go ahead and continue that. Okay, so what we've done so far is taking that COBOL program, build it as a .NET class library, added some .NET functionality to that, and then have a C# program that's calling that. Now, because I built this on .NET Core, we have the ability to run this on other platforms. So I'm now going to take this .NET application that I've built on Windows, and we're going to set it up to deploy it on a Linux environment. Okay, so to do that, I'm going to take the C# version of the program, and I'm going to publish it. Okay, so where I'm going to publish it is to a folder, and I'm going to specify a folder here. I'm going to take the default location for where I'm going to publish it. We'll just say finish. And it's created that profile. Now I'm going to make a couple changes to my profile, so we'll show all the settings. Now I've only set up the debug version of this, so instead of building the release, we're going to build the debug. And we're going to use .NET 6. And instead of making this portable, I'm going to set this to build for a 64-bit Linux. Okay, so we'll save that. Okay, with that done, I'm going to go ahead and publish this. Okay, so this is compiling the code and building it to move to a Linux machine. That's completed. So I'm going to copy the folder that it's placed that in, and I'm going to go to a command prompt. Okay. Now I'm going to cd to that directory where we built the code. And just do a directory and show you what's there. So we've got a couple of support libraries. We've got our Amort service dynamic link library. We've got our C# Amort, which is the C# program that's going to run this, as built as a Linux program. So now what I'm going to do is I'm going to push this over to my Linux machine. And again, I've got a little snippet to do that. dd.net directory. Okay. And it can't find that. Okay, so let's see if we can reset our IP configuration. Try that again. This time we find it. Okay, so we've pushed those components over to Linux. Now I'm going to switch gears and move into the Linux machine. Okay, so now we're on that Red Hat machine that I've pushed this to, and we're going to move into that dd.net directory. Do a directory, and you'll see those components that I pushed are in that folder now. Now the C# Amort program needs to be made executable, so do a chmod +X on C# Amort, and now we'll run that on Linux. Okay, so we've got C# calling COBOL on Linux now. So we'll give it a principal balance. We'll make it 250. We'll give it a term of months. We'll make that 180. And we'll give it an interest rate. We'll make that 7.85%. And we've called the .NET framework here. We've calculated out our end date, what was 180 months in the future. And we've run this on .NET. So started with a COBOL program, refactored out the functionality, built that as a COBOL.NET class, created a C# program that referred to the COBOL program, built as a .NET class, added the .NET functionality to calculate the future date, published this for a Linux platform, pushed that out to Red Hat, and on the Red Hat side, we've made it executable and run that. So we have C# calling COBOL using the .NET framework running on Linux.
Okay, so again, just to recap, and I think Jim did a great recap at the end there, so I won't dwell too much here. But again, we've got COBOL built as a .NET class library, no change in coding really occurring. We showed C# calling COBOL. The demonstration showed how the debugger could be set with breakpoints, which allowed us to show some of the seamless integration. We demonstrated the .NET class functions. They were embedded within the COBOL application. And lastly, Jim showed the portability of the entire environment. It had originally been a Windows environment, and now it is deployed to Linux running in Red Hat. We've talked through this series about an application journey, but it's primarily been that. It's been an application journey, but it is also the story of infrastructure journey or infrastructure modernization. So it's important to think about it in those terms. We have customers that come to us from various legacy environments. They may have been on a mainframe. It could be IBM or it could be Unisys or other. We have customers with distributed applications, And we're able to support those applications with whatever programming languages they'll be looking to integrate. So if they're .NET or a JVM shop, they can now access their legacy COBOL assets for integration. And, thinking about this again, an application running on a standalone workstation or a monolithic mainframe is now open to be harvested for other usages. And the functionality can be broken into a service. It can be exposed to new users or user communities. It can be extended to new customers via mobile devices or even into the cloud. And part of our support is how deployment is simplified in utilizing and supporting the use of Docker containers, Kubernetes,